Hi, everyone. Welcome to our June webinar about deploying AI ML development tooling at scale with Coder. Let's get everybody warmed up here in the attendee chat. Why don't you drop us a message? Let us know where you're dialing in from today. I am currently in Baltimore today, out of my hometown on the road, but comfortably set up in my hotel room to do the webinar. So okay, let's get started. Hi, my name's Tim Quinlan. I'm a Senior Technical Marketing Manager here at Coder. If you've been on any of these webinars recently, you've probably seen me, or if maybe we've met at an event or in a customer call. If so, let me know in the chat. That'd be great. I have a pretty tight agenda. We'll just do a quick overview of what the industry is looking like, what verticals are adopting AI ML this year, things like that. We'll talk about the benefits of it. We'll do a technical review. I have a pretty lengthy demo, and then we'll do Q&A. This demo is a little more technical than most of the ones we do on the webinar, or in the webinar format, but everything I do will be available in our GitHub repo. So it's really just a template in a Docker file, but it's a little more complicated than usual. So if you're new to Coder, one of the greatest things we can do is secure development environments, and it's all self-hosted, which means it runs on your infrastructure. It's not SaaS. You don't have to rely on any third parties. You can run it in your data center. You can run it offline if needed. I mean, you can run it in public cloud if you want, and we have plenty. We also have ones who want to do it offline. And everything I do today, with the exception of using Copilot, is offlineable. So if you were on our webinar last month where Rob and I talked about deploying Gen AI at scale with Coder, that was more talking about deploying the Gen AI plugins like Copilot and things like that. We have a blog series that has Gemini and Copilot in it. So that was more on the user side, although I did introduce the idea of using scalable Kubernetes clusters with GPUs enabled during that one. I didn't go into a lot of depth, but that's what today's. So the Coder benefits, and these are benefits of any CDE, really. If you're a Coder user or a CDE user, you can save a ton of time. Your devs don't have to set up their own environments. They don't have to maintain them. You have a Coder admin update the template, and it gets pushed out, and everybody updates their workspaces, and they're ready to go. So it eliminates a lot of patching issues and just tooling distribution issues. There's a lot of ways to save money with Coder. Obviously now you don't have to give your devs GPU-enabled laptops or workstations. You can give them, much less powerful workstations if they have to. But there's also a lot of cost controls we can implement at the cloud level too, scaling and some of the quotas and timers that we have on our workspaces. There's a risk reduction as well. You are giving your devs they're not out there updating their environments from public servers and things like that. It's very tight. It's very controlled. The speed to innovate is great. No longer do they have to wait to deploy tooling out to hundreds or thousands of devs. You just update the template and away they go. And developer retention, we've found that a lot of folks, they can use Coder as a retention tool, because they can tell their folks, hey, we can get you on the latest tooling. We can get you with the latest IDEs. We can get you GPU-enabled instances. We can get you big memory instances, all for cheaper than they can if they give them bigger workstations. So the devs love it, and it's a great retention tool as well. So what does this look like when we mix GPUs in? All the same things apply, right? Now you don't have to You don't have to deploy that hardware, so you're saving time. You can maximize your core usage, so you can reduce costs there. Uh, Once again, risk reduction. You're not, you know, all the tooling can be, all the AI ML tooling can be installed, by the admins at the workspace level. Once again, speed to innovate, that's the same. You can get the tooling out to your devs in very little time. And then once again, it's a developer retention device as well. So what does Gartner say about AI and ML these days? 3 out of 4 CIOs are increasing their investment in 2024. And this is across all sectors and all verticals. This is nothing specific. This is just very general. The highest adoption rates they're seeing are in insurance, healthcare, oil and gas, and utilities. I guess oil and gas is probably the drilling and exploration side and distribution side, whereas utilities is the retail side. You can see these are not your typical, super high tech verticals, right? These are regular, companies where they're, maybe consider them more conservative, or whatever you want to say. But you're not dealing with FANGs or fintech or anything like that. I mean, these are just regular good old companies, right? And the verticals with the most aggressive spending, the same sort of thing: insurance, healthcare, banking, and transportation. These are not not your super high tech companies, but this is where the money is being spent. So if you're in one of these verticals and you think, well, we would like to do it, but whatever, we're just not that kind of company. Your competitors are doing it already. So what does Gartner say about the problems that people see when deploying GPUs? The inhibitors, security and privacy risks. They are worried about using public AI and language models and publicly available plugins and things like that. They want to maybe move it in-house, okay, or even run it completely offline. If say they're developing a sort of block that off from the world, they don't want anybody seeing what they're doing, you can do that as well, right? Technical preparedness, once again, are they ready to deploy GPUs and AI ML software out at scale? They probably aren't. Predictability of business value. They don't know what they don't know what these tools will what for to experiment. And access to human resources, getting developers who know this stuff and want to work on it. As we mentioned before, using a CDE like Coder can be a great retention tool, or even an incentive for a new hire to come in who knows these things. So Gartner states the near-term actions that you can do. You can offer gated low-risk value adds. This is like Copilot or Gemini at scale. We'll kind of see that in this demo. That was more last month's webinar. But those are using those publicly available models that people want to use, and they can help with your devs doing day-to-day coding, but those aren't really for developing AI ML itself, is what we'll see today. Offer easy-to-use experimental environments to prove value. This is an excellent case for Coder. As you'll see in the demo, you could create a template with some AI ML tools in it and spin it up, and your users could have access to it and be running to it within minutes. And then insulating your AI ML development environments from risks, both well-known and obscure. Once again, these are all things that Coder can do and really accelerate the adoption rates. So, common GPU deployment methods. What are people doing nowadays? Relying on physical servers or monolithic VMs with GPUs enabled on them. This works. However, it's less than ideal. In our opinion, it can be extremely expensive. The users sometimes have to play hopscotch. We had one client who they had dozens of GPU enabled boxes, and every morning at 9 o'clock, it was a race to be the first one on one of the boxes, and or even throughout the day, logging in and out to try to find one that wasn't as heavily utilized, so they could get their own core. And these things also run 24/7, so they're expensive. Even if you're using physical servers in-house, they can chew up a lot of power. But if you want to run monolithic VMs in the cloud 24/7 with GPUs enabled, it's going to cost a lot of money. Another way that people are doing it, or they're using VM workspaces. Now, this is a very common thing that coder customers do, right? This is great because it takes advantage of the resource separation and cost controls that Coder offers. So you could have a VM with one core, and you could give each one of your developers that, and that's great. And you could put quotas so they couldn't spin up too many. You can have timers, so it shuts down at 6 o'clock or an hour after they log off or whatever it is. So there is a little you can get some advantages when using a VM workspace, but they're still resource intensive, right? They still require a VM. They still require more storage and things like that. So how do we get around that? We talk about using Kubernetes to get around that. Why do we want to use Kubernetes? Auto scaling, it's built in. We can take advantage of that with Coder, and we'll see that in the demo. We can do tiered workspaces as well. And what I mean by that is you could have different templates on different nodes, or more resources per node, or whatever it is, and different groups could be assigned to the different templates. So you could have your developers on the larger instances, and then you could have your testers on the smaller instances, or however you want to separate it. That's entirely up to you. And it's a great way to provision GPUs, right? So the auto scaling, like I said, it's platform native. And we'll see it. The tiered workspaces, you can use Coder's RBAC features. That's part of Coder Enterprise. And like I said, you can have one group with one set of templates and another group with another set. It's really easy to use. And then the GPU provisioning, you can really lower your average cores, because rather than just saying, each user can get one GPU and run them all the time, what you do is you're going to have one core, two cores, whatever it is, and you let Kubernetes schedule it on an available server that's there. And then once the limits for that server are reached, however you set those limits, whether it's by core or by just the amount of pods, then it'll just spin up another one and keep going. So then as your users log off overnight, those nodes all scale down. So rather than running a core per dev all day long every day, they're really only provisioned when they're actually using. And this is a lot of inherent savings. We had one customer report that they were saving $60,000 per month just by going from going from monolithic VMs to using auto scaling with Kubernetes. Huge savings, huge. So what are we going to talk about in the technical part? We'll talk about the Kubernetes features that we need to look at. And this is all done on GKE. That's the cloud that I like to work on. But this would apply to anything, whether it's AWS or OpenShift or some other just raw Kubernetes or upstream Kubernetes that you're running in your own data center. But the examples are GKE specific. We'll look at what Coder features we need to review. We'll look at the Docker file that I made for the workspace. It's pretty simple. And then we'll also look at what the template is. So what we need to focus on the platform side is how do we get the GPUs provisioned and how do we install the drivers, all right? How do we define our node groups? And then how do we taint and label our nodes? The reason we need to taint and label is you don't want a you don't want a component from your control plane landing on one of your GPU nodes, or you don't want a developer who doesn't need a GPU landing on those nodes, right? And vice versa, you don't want somebody who needs a GPU landing on a node that just has CPUs. So what we'll see is I have 4 different node groups in my cluster, and we'll go through what each one does. So how do we do the driver installation for the GPUs? It's handled on the node itself. There's nothing that you can do in Coder to do this. It's something that needs to be enabled on the node. I have selected just to allow GKE to install the default driver and maintain the default driver. You may want to have that option. You may want to do it yourself. The option is there. It's yours. This node, this is for my GPU large node group. It may not look that large to you guys who are doing this, but for a dev environment, for just doing a webinar, it's considered large. It has 4 Tesla cores in it. And keep that number in mind, because one of the examples we'll see when we provision how we can limit the amount of cores that one user is going to get. So just keep that 4 cores in mind. Like I said, I have 4 node groups. You can see the one is called database and control plane. There's no auto scaling on that group. You never want to auto scale your database and control plane with Coder. Typically, you just would select the amount of nodes that you would need for HA and only allow 1 pod per, and then bump them up to use all the resources they can. Small, I have the database and control plane running on 1 node. It's fine for these purposes. I have a GPU large group, and that's what I just talked about. It's an N1 with 2 cores and 4 GPU cores, and I have auto scaling on that. I have a GPU small, that's an N1 standard, and I think N1 standard 1, and I think that only has 2 cores on it. And then I have workspace, which is just my default. If it's not scheduled to be on a specific control plane or GPU node, it will land on workspace. So there's no taints there. I do have them labeled, but it really doesn't come into play. It's just sort of a default catch-all group. So this is what these things look like when you use Kubernetes. To see, I sort of highlighted every other node group here in green, and you can see that the top group is my control plane group. I have it labeled as tier equals control plane, and I have it tainted as tier equals control plane, and the effect is no schedule. The next group is GPU large, same thing. I labeled it GPU large, and then GKE puts the taint in of NVIDIA.com GPU equals present. And there's no schedule. Excuse me, the label is NVIDIA.com GPU present, no schedule. Now you can see the next group has a different tier name, but it has the same taint as above. So keep that in mind too when we look at how we do node selection with the workspaces, because we'll specify both of those values to separate them out. And then the last one is my workspace group. There's no taints there. They are labeled, but I ran out of space on the screen. Not that it really matters anyway. So the Coder features that we need to look at, we need to look at node selection and toleration. We need to look at requests and limits as well, and then we need to talk about RBAC. So then there's two places you have to set your node selection and your tolerance. You have to, for your control plane, if your control plane is running on Kubernetes, you have to do this in the values.yaml file, which is the file when you deploy the Helm chart or you update with the Helm chart that it gets its override values from. As you can see, I just said my node selector, I want it to be tier control plane, and I want those pods to tolerate the tier is control plane and the effect is no schedule. There's also one, now that I think about it, I forgot to put it in here. There's also one for the database as well, but it's the same format. It's just a values.yaml. You're probably not running your database in a pod in production, so most folks aren't going to worry about that. And then on the workspace side, in the template, in the deployment spec, or the pod spec, if you're using a pod, there's a node selection and a toleration there as well. So we see what tier we want it to land on and what tolerations or what taints to tolerate, right? So this one is going to land on GPU large tier. and it's going to accept the taint of that there's a GPU present. If we wanted one to land specifically on GPU small, then we would just change that tier to GPU small. You need both the node selector and the toleration if you have node groups that are similar. Since both of the node groups, the GPU large and the GPU small, since they both have the same taint of NVIDIA.com GPU is present, then no schedule, then you also have to have this node selector in there. Otherwise, the workspace isn't going to be declarative enough or specific enough, and it'll land wherever Kubernetes can schedule it if you didn't have the node selection in. And that could run into some problems, because if you had, let's say you had a GPU large, let's say you had, I don't know, like 16 GPU cores on there, and you were allowing your devs each to get 4 cores, and then let's say you had a testing tier and you only had 2 cores on there. If you tried to schedule, if you allowed the pod or the deployment to get scheduled on that smaller node, the workspace would fail. There wouldn't be enough cores there to match what it's requesting. So here are the requests and limits. If you've gone through our templates ever before, you may have seen this. So we have requests, which is the default value that Coder requests initially when you create a deployment. And you can see that it's a quarter CPU and a half a gig of RAM. And then in the limits, we have CPU and memory. These are parameters typically. Code values in here. You could, hard code 4 CPU cores and 8 gigs of memory or whatever. But a lot of times, a lot of times we have the option that the users can pick when they start the workspace. They may just go straight for the big ones. I don't know. Anyway, the GPUs are a little bit different. The request and the limits have to be the same. Coder can't request and say, hey, give me half of a GPU, but let them burst up to 2 or whatever. They have to be oversubscribe your GPUs. That happens at the platform level, and your mileage may vary on that. I've tested it. It's it works for what I do. I don't know if it would work for what you do, but there are ways at the platform level at the to define to allow GPU sharing. So what you could do there is, you could say, let's say we give each developer 2. When the 5th developer starts up, it's going to trigger a scaling event. It's going to start a new node. If you had GPU sharing enabled, you could say, allow 8 on this node, and basically you're oversubscribing the GPUs by 2. But your mileage may vary with that, but it is possible. And then finally, RBAC. This is a bit of an eye chart. I apologize, but these are screenshots from the Coder UI. You can see that the top one is called, the top one is our CUDA, OLLAMA, and Copilot template, which is what we'll be looking at later. And only people who are in GPU users, can access that template and build a workspace from it. And the one below it is GenAI GitHub with Copilot. Anybody can use that, and that actually points towards GPU small. So basically, to deploy your workspace on GPU large in this cluster, you need to be in the GPU users group. That's what it comes down to. This is the Docker file that I created. If you've ever seen the Coder Docker file, this is going to look really familiar. Essentially, I changed instead of pulling from Coder Enterprise, I changed this to pull from the NVIDIA CUDA image. And then there's a couple of packages that aren't included in there that are included as well, because Olama needs that to see if there's a GPU to use, and we'll see that in action later. But like I said, this is it. This is all the code I had to write to enable it at the container level. I just took the standard Docker file and changed a couple of lines, and away we go. And of course, I had to build it and push it up to to a registry, but that goes without saying. So here's the template changes I did. I built off the template that we talked about last month, the one that had Copilot on it. So I still use the same module to install Microsoft's VS Code Web. This one doesn't have Code Server on it, just has VS Code Web. And if you recall from last month, the reason we do that is Coder cannot connect directly to Microsoft's marketplace for extensions. Or Code Server, excuse me, can't connect, but Microsoft's VS Code Web can. That is the only reason I chose it. It works just as well as Code Server. We are agnostic. You can use whatever you want. And then I changed the startup script. All I did was add one line to install Olama, and then another line to start it and log it. That's it. Now I have a little asterisk there. Didn't really have room on the screen, but we've already seen it. We need to add the node selection and tolerations and the requests and limits, as we saw earlier. If you look at the example files that are in the GitHub repo, it's all there. It'll all be there in line. So now it is time to demo. I'm going to share my screen. Whoops, excuse me. Okay. And then can somebody in the chat let me just verify that that you can see the screen share?
Yeah, we can see this screen share.
Great, thank you. Thank you.
Oh, we see the lead studio. Yeah, there you go.
There we go. We can see the workspace.
Yes.
Okay, so like I said, the files that we're looking at are pretty straightforward. We've seen this Docker file. It's nothing special. This is sort of the bare minimum to get things going. Of course, as a customer who has, hundreds or thousands of users using their templates, yours are going to be a lot more complex. But you could take these lines and apply them to yours, no problem. And then we'll also look at the template. If you are familiar with Coder and templates, this will look familiar as well. This is the basic Kubernetes deployment template that comes in our starter pack. There's nothing really special about it. Like I said, I added the VS Code Web installation with Copilot, completely optional for you guys. And then the startup script, you can see I have I removed the Code Server line, and I have the lines for installing Olama and starting Olama, and then I have the same thing, the limits and the requests, just like we saw before, and then the tolerations. This one will go to GPU large, and it will tolerate having a no schedule taint based on NVIDIA GPU is present. So really straightforward. I changed 2 things in the Docker file. I added 4 things to the template, and that's all we need to create our workspace. Oh, and also, actually, now that I think about it, I'm pulling the image from a different place. Maybe 5 things I had to change. But if you're using Coder already, you probably are pulling your own image. So that's that. And if we look at the workspace, it's pretty straightforward. It's pretty simple. We have VS Code Desktop, we have VS Code Web, and a terminal. We can everything we'll do here can be done in any of these. Let's just take a look at VS Code Web. because this is going to be a pretty straightforward. Give that a second to spin up. I am on hotel Wi-Fi, so hoping that's not going to affect me. While that's spinning up, let's take a look at our cluster. So if we take a look at our pods and see where they're landing. Oh boy. Marco, can you still hear me?
Yes.
Okay. Oh, there we go. I'm having some latency issues with the hotel Wi-Fi. I apologize. You can see that I have a bunch of different. Oh, there's an unscheduled pod. I wonder what's going on there. Anyway, I have my control plane that's running in my control plane group. I have my database that's also running in my control plane group. I have a regular workspace running in my workspace group, a regular GPU small running in there, and then my Ollama 1 running in GPU large. And then, let's see, did we get, yep, there we go. So I'm not going to bother signing into Copilot. We don't need that for our purposes today. So remember now that the node that this is running on is actually a 4-core node. It has 4 Tesla cores. But since we set the request and the limit at 2 cores, when we look, did I pick the right? Oh, sorry, I picked the wrong one. Sorry about that. So while this is warming up again, I apologize. I picked the wrong workspace. Remember that we had 2 cores set as the limit, but the node is actually running on 4 cores. So when we look at NVIDIA SMI on here, let me just blow it up a little bit, but I'm not gonna worry about that. Actually, let me shrink this down. There we go. When we look at the terminal on here, we see that there's 1 and now there's 2 cores. So I've only subscribed half of my cores of the node to this 1 pod. If I start another workspace with this template, it will land on that same node most likely. And then if I start a third, it will most likely spin up another node and go from there. So what else did we do? What else did we take a look at? Oh, I installed Ollama on here. Let me see, is it running? Nope. So let's start up. Let's just start up Llama 3. That's the basic, the most basic GPU or most basic AI/ML that you can run. And let's just do this. Let's watch. Now you can see that this first core has woken up a little bit. Ollama only runs on 1 core, so we're never going to see the second one fire up. But I'm sure if you're only doing single core stuff, you're only going to deploy 1, or if you're doing more complex stuff, you're going to have multi-threaded things. So now you can see, okay, Ollama's up, it's running. We can see that the GPU core itself is activated. There's about 5 gigs of memory there. And now we have an AI/ML model running on our workspace, right? So we can prompt it here. All right, and there we go. So this is all running on the workspace itself. You don't need any outside connection. You could run this completely offline. Another option you would have is you could actually run Ollama, like run an Ollama server inside your data center if you're running offline, or you could do tab 9, or there's a couple of different ones where you could run offline and connect to those. But the reason I installed it on the workspace is just to show you, hey, here's how you can, here's some GPU enabled stuff to run. So I'm not a AI/ML developer, so I don't really know a whole lot about what tools to run. This is the one I know. So it's there, it's running, and we can see it, and it's humming right along. Now, if we want to look at, let's spin up a couple of more. Oh, there's an update. I didn't see that this morning. Let's spin up a couple more workspaces, and this will just be a regular CPU one. Let's spin up another GPU large one. Actually, let's spin up 2 of these and see what happens. Oops, sorry, hit the wrong button. And then when these are spinning up, we'll do some Q&A, because these are going to take a few minutes to come up, because, sorry, I keep hitting the wrong thing. Okay, let's do that. And then I have this CUDA small. And we'll see how these all go. That should trigger scale-ups on both node groups. So now let's just take a look back at Kubernetes. Yeah, so you can see that these are pending. If we describe this pod, this is one of our GPU small ones. Actually, this one. There, you can see that we've gone over the limit. That node only had 2 cores. We tried to schedule 3, so it triggered a scale up. And then if we look at the last, GPU large, which I misspelled, we will probably see the same thing. Yep, pod triggered scale up. So it's going to take a few minutes for those to scale up and get going. So let me just go back to my slides really quick. Stop sharing for now. And if we have time, we can go back and look at the nodes and see what they're like. So just to wrap everything up, while the scaling event is happening, like I said, if we have time, we can go back and review it. Everything is going to be available on On24. The slides will be there, and links to the GitHub repo where the examples are. And if you grab the slides, the links are right here. And then links to our previous webinars and blogs. We've done a few on AI, ML, and Gen AI in the last couple of months. It's been a really popular topic. So if you want to have a bit more of a primer on it, you can go back and review those if you missed them. So, and then next month, we are having some special guests from a very large global financial services company, and they're going to be sharing their coder journey with us. We can't say who they are at this point, but if you want to tune in and learn about it, you can. The link is right here in the slides, and I see that Marco has just put the registration link in the chat. Also, if you just go to our webinars page, you'll see it there. And that is it for the demos and all the wrap up and everything. Marco, do we have any Q&A? Let me see.
Yes, we have one question. Could you wipe LLMs from workspaces?
You could. If you were restricting which LLMs they could install, you could easily update the template to run you know, like let's just say if you're using Olama, you could do an Olama RM, you know, whatever one you want to wipe, and then however you set up the server where they would be pulling the LLMs from, you know, you could just restrict it there as well. So you could take it away and then also restrict it at the kind of provider level, I guess you could say. But the thing with Coder and CDs in general is these workspaces should not be pets. They should be 100% ephemeral. You should be able to just wipe out a workspace and then have them rebuild it, or have your devs build a new one. You know, they shouldn't really be saving anything important on these. Everything that they do should be, you know, just like any other, you know, any other software development practices that you're following. You know, all your code should be checked in when it's ready to go. You know, this shouldn't be the only spot where something important lives. So if you did have some LLMs you wanted to wipe, probably the easiest way to do it would be to go in and just see which workspaces were created from the template that you want to wipe, or the template that you suspect has some, you know, LLMs you don't want, and just wipe all those, or just destroy all those workspaces and tell the people, hey, you know, you just got to rebuild. It's that simple. So yes, you could script it, but to be safe, I would just destroy the workspaces. Any other questions there,
Yeah.
Marco?
Yeah. Can you install Microsoft VS Code Web without using the Coder module?
Yes, you can. There's a bunch of different ways to install it. You know, you could in the Docker file, you could, you know, use your OS package manager to install it there. You know, you could just do like a wget of the file that you want from wherever it lives, whether you have a special version in house or, you know, you just pull in Microsoft's latest, and then do the install right there, and then it would be available for, and then you could just use the startup script to start it. You could also put those commands in the startup script itself if you want to install it every time. You know, some people do, some people don't. Sometimes what they'll do is pick a specific, they'll host a specific version internally and just have it install that every time. And it's fast enough because it's local. You don't have to worry about it. You know, they're getting the same version. That way, if you want to update, the version of Microsoft VS Code Web that they're using, or really anything that you're installing, you just change it at the template level, and then the next time they rebuild, or they'll get a notification to update their workspace. It'll bring the pod down and bring it back up with the new configuration. So yeah, you can. There's a lot of different ways to install software in Coder. We saw 3 of them today, right? We baked LSHW and CUDA in with the Docker file. We used the module, obviously, to install VS Code, and then we used the startup script to install Olama. So those are the 3 typical ways of installing software in Coder, and you have to determine what's right for you, right? We can't prescribe one single way of doing it. You know, if you're just getting started out, startup script's great, modules are great because everything's right there, it's in the template. But as you get bigger and bigger, and your images or your software that you're installing gets larger and larger, you want to start looking at moving stuff into the image when it's right for you. Next question.
Yeah. Will this work in an offline data center?
Yes. Everything in that template will run offline except for the Copilot VS Code plugin. The method that you would use to install Microsoft's VS Code Web would have to be different, because pulling or installing with a module pulls from, you know, it just runs a command, basically a startup script that pulls the module down from the internet and installs it. But if you installed VS Code Web with the Docker file, or if you hosted it locally and pulled it from there and installed it, that would work. And then obviously Copilot isn't going to work offline, right? Because that needs a connection. But if you had, let's say you had a LLM running internally, like let's say you had an Olama server running, or Tab 9 or something like that, yeah, you could easily install that rather than Copilot. So, and then the Olama stuff, all you would have to do is either bake that in to the image, or just host it internally, where you know, where have an Olama server where they can pull the modules from. So yeah, pretty much anything that you want to do in Coder, you can do offline. Coder doesn't need that many doesn't need to pull that many resources to run. If you want to run offline, the big things you have to do, you have to replicate the Terraform registry. Just, you don't have to replicate the whole thing, just the Terraform providers that you need. It's pretty easy to do, and obviously have your own container registry, and then have your own plugin registry if you're deploying plugins. And we actually have a open source project that where you can run your own VSX registry internally. We have some really good documentation and guides too on our website about running offline. So any more questions? Or
that's it for the questions.
Okay. Actually, let's take one quick peek back at our let's take a look here and see. You can see all those web spaces are up and running, or workspaces, excuse me. Now let's take a look and see where they all landed. Let's see. Well, we had one problem. Oh wait, this is not what I'm looking for. So, there we go. So now we can see that there are a bunch of nodes. Let me see if I can get this over. Here we go. We have a bunch of different GPU larges running. We actually have 4 GPU larges running, and we have 3 GPU smalls running right now. I would imagine what would happen now is, if we go in and start shutting these workspaces down, and you can do that either manually or with we'll leave this one running. You can do it manually or with the UI or the CLI or the API, or you can also do it with the timeouts, the cost controls. If you stop all of these, eventually all the Kubernetes auto scaling will start reeling those nodes in and deprovisioning those nodes, and that's where a lot of the cost savings comes from. We don't have time to sit and wait for that to happen. That's probably going to be a couple of hours before those nodes get pulled back in or get reeled back in. And that is it for the content. Like I said, if you grab the slides, it'll have all the links in it. If you go to GitHub, github.com/coder/webinars, we have an archive of all the materials there, and there's links to all the past webinars as well. Coder.com/webinars also has links to all the past webinars, so you can catch up on all these things. We are just a few minutes shy of time. I think, Marco, at this point, we just give everybody 10 minutes back, and we all have a great day. What do you think?
Yeah, that sounds good. Thanks for everyone for joining.
Okay, everybody, thanks. Hopefully we'll see you in the customer queues. Bye.